Hello and welcome to the data video part 2. So we were investigating the Titanic data set and we had just looked at the use of the contingency table created from StatCrunch. However, this basic contingency table that is presented in the problem is all you actually need to answer basic questions that aren't graphical displays. So the very first thing you need to do is total the values, and I've done that for us again in order to save us time. So total all the values along the row and the column, and then you can answer as many questions as you need from the table. So what is the probability that a randomly selected third-class passenger survived? So always make sure you're doing a probability statement. Probability all right, randomly selected third class passenger. That means that's a specific type of passenger. That is a third class passenger. All right, and we are looking that they survived. That is, we're going to call them A, alive. Then again, you can use the definition of conditional probability to do this, or you can just look at the table. Those that are in third class, that means I'm only looking at this column. That means I already know the denominator. That is 706. Then, of these that are in third class, which of them are alive? Oh, the 178. And it is that simple to identify these problems using a table. Very, very straightforward. Read the problem carefully. Make sure you understand which piece is the denominator, which is the numerator. Writing out a probability statement is very helpful as well. I'm going to do that one again. What is the probability that a randomly selected survived passenger was in third class? Notice, survived passenger. That is a specific type of passenger. That means given the passenger is alive. All right, what's the chance they are then in third? So looking back at our chart, they are alive. That means I'm looking along this row, this top row here. So that means the denominator is the 711. Then in order to identify the numerator, once again, I'm looking for the of those that are alive, who was in third. Once again, look, it's that 178. So notice, same concept, but different denominator based on the condition. One more. What is the probability that a randomly selected passenger was in third class and survived? So notice the difference on this one. Probability randomly selected passenger was in third and survived. That means out of everybody. That's out of the 2201. That is the entire population in this case, the entire sample. All right, then probability third and survived, that again is the 178. So notice the numerator uses that 178, but the denominator changes in each situation. So you have to read these problems very carefully. And again, when making pie charts, when making bar charts, we will use StatCrunch, all right? We will enter the data column-wise. Occasionally, if you want, you can get all the same information with the contingency table. However, it's usually just easier to identify that information by thinking about the problem and understanding. All right, let's continue on. And actually, I want to look at the data activity number 1. So the first data activity refers to the politics and gender data set. And a lot of these questions are true-false questions, and I just want to make sure that everyone is getting a good start in creating these problems. So the politics and data gender set, I've given you the table of information here, and then I want to produce a graphical display of the marginal distribution of politics of the class. So once again, pie chart with summary. So graph, pie chart with summary. And then we are specifically looking for distribution of politics. Oops. Counts and count. I could title it, but no need here. And create your graph. Then check, is that what we were looking for? That looks like the appropriate graph. All right, so true. Again, our goal here is just to create the graph. Then I can ask questions. When identifying these questions, all right, our whole purpose here is just to look at the data and then pull the information out. I don't actually need, all right, to create a contingency table like I did before, just using StatCrunch. Just look at the information visually. And I can use like the pie chart and stuff to do this basic information. What % of the class is male? Now, that's just summing this value up, 50 plus 44 plus 21 out of the total number. But I can use StatCrunch to actually speed that up as well. Pie charts, category, sex, counts and count. And oh look, 115 out of the total, which is 192, which gives us 59.9%. Now, as a note, all right, enter all questions refer to fractions, percents, probabilities as probabilities. So that means enter this as 0.599. And then refer to the data set, politics, and gender. All right, once again, what % of the class considers themselves to be conservative? So that again, I already have in this question. Conservative, the 27 out of the 192, 14.06%. Okay, and I could answer all kinds of questions. However, I want to jump down to number 7 here. Students in an intro stats course were asked to produce a graphical display of the conditional distribution of politics among males. So this, once again, is a given, all right? Politics among the males, all right? Notice the next question is politics among the females. These are those conditional pie charts. In order to make those, pie chart with summary, politics, counts and counts, and among the males. So that means sex equals male. Again, case sensitive, all right? And as a note too, if it's multiple words, you can put this in quotes. It won't change anything. So, but if it was male space 1 or something, put it in quotes and hit compute. Similarly, I would do that same graph, pie charts with summaries, categories as politics, and sex equals female. Conditional pie charts are one of the biggest uses to identify if two things are associated or not. Looking at these once again, are the pie charts the same? Of course not. I can look at that and visually see that they are not exactly the same. Then compare with specific probabilities. 8% of conservative 8% here is not equal to conservative 18% here. Actually, 45% and 43% are pretty close, all right? But that would be the only one. 47% is not equal to 38%. In order for them to be independent, all the percentages have to be within 4%. So even though just liberal here is within like 2%, right? That's the only one. If they're not all within 4%, then it does not work. All right. So that means gender and thank you. Excuse me. Gender and political affiliation are dependent events. They are related. All right, which is what I typed on the document here, because again, when you pick, all right, a specific value, conservative given female, conservative given male, you compare those probabilities. If they are not within 4%, then the events are dependent. This is one of the biggest things that we are going to do with StatCrunch. Basic pie charts, nothing fancy, all right, nothing extravagant. Simple pie charts tell a grand story. All right, thank you very much, and I will see you in the next video.